Hello, I'm Travis Brungard. Welcome to the BS and Beer Show. Of course, BS stands for Building Science, and tonight we're discussing building with remodeling in mind. We've got everybody drinking, of course. I'm actually not doing so hot lately, so I went with coffee rather than a beer tonight. I got to stay sharp. I don't want to miss anything Ted delivers tonight, so I got to have my wits about me. But you should all be introducing your beverages and enjoying yourself nonetheless. I want to take a minute to just encourage the local building science and beer discussion groups. I know we've had a great amount of growth. I think Mike told me there was one in Australia. They're everywhere. They're popping up. So if we can help you to get one started, please let us know. We're happy to do that. You can email or DM or all sorts of those options. I wanted to really quickly mention that coming up, we'll have an announcement going out about the Building Science Symposium in Kansas City on September 16th, at Boulevard Brewery. And then I think is it next week, Mike Maines, the Nessie night?
Yes, yeah, next Wednesday through Friday, and I'll post a link, but it's based in Boston. The Northeast Sustainable Energy Association has a good conference every year, and it's going to be virtual this year. It's 3 days packed full of information, including our regular Thursday night BS and Beer is going to be part of the Nessie after party, they call it. So,
woohoo! Looking forward to celebrating that.
Yeah.
Well, if you want to get on our email list, you can sign up and we'll send you links to the recorded shows. Of course, that's also available at thebsandbeershow.com. And then, of course, you can chase it down at Green Building Advisor. And that is a really nice segue into thanking our wonderful sponsors and partners in this, Fine Home Building, as well as Green Building Advisor. And that brings me to introducing Brian Pontalillo.
Oh, yeah. Hey, everyone. I guess, well, it doesn't matter. It says Fine Home Building. I'm Brian Pontalillo from Fine Home Building and Green Building Advisor. Welcome to the show tonight. We're excited to have Ted on, and the topic that we're going to get into tonight is important and detailed, and we could cover it in a lot of different ways. And it made sense for us tonight to let Ted really have the floor for a while, since he's put a lot of time and thought into this. So I say that because it's usually my job to introduce how the night's going to go, and how tonight's going to go is pretty simple. We're going to turn the floor over to Ted in a few minutes, and he's going to present on how he has handled and how he thinks it would be smart to handle the ideas of reversibility and flexibility and adaptability in home building. So I'm really looking forward to that. As Ted presents tonight, you're welcome to chat in the chat box. I know you all know that, and you always do. And it's also where you can post your questions. Make sure that you're selecting all panelists and attendees when you post your questions, so that for a couple of reasons, so that other attendees can help out maybe with some answers, but also so that we see them and we can ask your questions of Ted. So we'll move into a discussion when Ted's done, and then some Q&A. And before I pass it over to Mike, and Mike, I hope I'm not stealing your thunder, but I didn't look at the agenda for tonight. And so I do want to remind everyone that we have the BS and Beer Book Club in process, I guess. We're all reading The New Carbon Architecture, Bruce King's book. And on September 24th, Bruce is going to join us on the show, and we're going to have a presentation from Bruce and a Q&A with him. So now's the time to start reading the book if you haven't already, to get it if you don't have it. And we hope to see you on the 24th. And with that, Michael Maines.
Thanks, Brian. I'm Mike Maines. Tonight I am drinking a ginger kombucha, technically a brewed beverage. Brian already talked about book club. Travis talked about Nessie, so I'm going to go right into introducing Ted. It is my honor to introduce Tedd Benson, author, building pioneer, founder, and CEO of Benson Wood, Unity Homes, and Tectonics, based in Keene, New Hampshire. Ted was one of the founders of the Timber Framers Guild of North America and has written 4 books on the subject. I think I have 2 of them, maybe 3. Ted, through Benson Wood and later Unity Homes and now Tectonics, have been leaders in advancing technology and thoughtful processes in the construction industry, everything from computer-controlled cutting of heavy timber for building structures, using CLT, cross-laminated timber for buildings of all sizes, to the development of new systems, processes, logistics, and technology that focus on making high-performance and sustainable homes the industry norm. On a more personal note, Ted was instrumental in getting me into this field through a project in the 1980s on TV's This Old House, which got me excited about timber framing and energy-efficient construction. I even visited his shop as a teenager. Although Ted wasn't there, he was called away to some important build out in Colorado or Montana or something. I did, his operations manager, Dr. Ben Brungraber, was very generous and spent a couple of hours with me, giving me a tour and helping me, basically steering me towards a college program that would prepare me for a future working on their team, which I never did. But I have carried the principles I learned 30 years ago with me, and I believe I recognize Ted is in his shop, and as I recall Ben telling me 30 years ago, I think each of your bents there are different materials, right? There's a purple heart and a mahogany and a Doug fir bent, something like that. So the lessons really did stick with me, so it's really an honor to have you here tonight, Ted. So yeah, Ted, welcome to our show. Please let us know if there's anything else you'd like to add, and of course what you're drinking tonight, and then go ahead and launch right into your presentation.
Great. Well, that incredibly humbling, Mike. That it's a little over the top, but I'm actually glad that you were able to meet Ben instead of me. That was a whole lot more fun and very, very knowledgeable. And yeah, the timber frame shop behind me was designed by Ben, so he's still here in spirit for sure. And I am actually drinking water out of my bike water bottle. And right after this, I need to get on my bike. And it's pretty important that I spend more time on the bike than beer, or I'm going to have to buy new pants. And that's not happening. So it's water for me until that weight goes down. And I got to tell you, it's a real honor to have the opportunity to talk about this. This has been an incredibly important topic for myself and for so many people in our company. And you know, although you introduced me, Mike, everything that we have developed here has been a team effort. And I'm just incredibly lucky to be surrounded by a group of talented, creative, dedicated people, and I get way too much credit. But they're all out there somewhere, and as I talk about it, you know, I may self-reference a little bit, you know, to tell you some stories. But this has been a team effort and remains that way. Looking good. Okay.
Yeah.
So this is about what we call open built. It's our version of open building, and I'll tell you a little bit about that. And what I'll be describing are kind of the principles and some innovations for building more adaptable, more durable homes. We all, I think, as builders have always, you know, we've all aspired to build something that is durable, and I think we tend to focus on, you know, the engineering of the building and the architecture of the building, but we don't focus enough on the adaptability of the building. So that's really what this is about. And I have my personal reference here is I'm a part of a very large family. I'm the middle child of 11, and I grew up in Colorado. And when we moved to Colorado, we first lived in that 900 square foot wooden tent you see in the upper left. And it was, you know, it was awful, and it was awful not just because it was small, but it was poorly built, and it couldn't contain our family in a way that would be useful for our lives. So fortunately, in 1956, my dad found a house that was scheduled for demolition, and and creatively managed to buy it for $1, have it moved to the north end of town on a lot that we could afford. And we spent, the rest of our lives, growing lives in that house, changing it, adapting it, and living, living in a much more useful kind of building for a growing family. But the story of the house is really interesting. It was built in 1895 by a gold miner for his sister. And, obviously he was quite wealthy, and this was a nice gift to get from your brother. But, she lived there basically alone with some servants in that house. And so originally it was built for one person and staff. So she lived until the 1930s, and the house kind of went downhill in the Depression, and in that period it became an apartment building. And it was broken up into 3 apartments, one on each level. So that meant there were, kitchens, dining room, bathrooms on each level of the house. And so from there, it kind of went downhill to the time when my dad bought it, because it was scheduled for demolition. And when we moved into it, it was still set up like, for 3 apartments. But that meant that, all of the kids actually had the opportunity to have individual bedrooms. But we had to be creative. So my bedroom on the 2nd floor was actually the 2nd floor kitchen. And as a kid, I guess I was 12 or 13, I learned how to take cabinets out and cut pipes and turn a kitchen into a bedroom. And the house, which was obviously, pretty simple at the time, had really good bones, but it didn't have a lot of infrastructure in it. It really allowed that adaptation easily. A kid could do it. That was me. And as a result, over time, that house contained 11 children and my parents with dignity, and it changed our lives. Just totally changed our lives to be living in a building that was that well built and that adaptable. I can tell you that the house today is going uphill, not downhill. It has a new family there that has had more resources, financial resources, than we had. And so it's in better shape than it's ever been. And, there's every reason why that house is going to be there for another 200 years. That house is the reason I'm a builder, because I know homes matter and can change lives. So later on, when I got into building, I had experiences remodeling homes in the Concord, Massachusetts area, and then later up here in New Hampshire in the Walpole, Alstead, Westmoreland, Ackworth area right around me. And most of the homes that were being remodeled are the old homes. There are many, many old, amazing homes in this area, as there were in Concord, Mass. Some of them 250 years old or older. But they were so well built and so adaptable that renovations were pretty straightforward. There wasn't a lot of hidden infrastructure. It was easy to move partitions around because they were all timber frame buildings. So you could reconfigure bedrooms and put bathrooms in, and that's the story of those old homes. So when I got into building, I really decided I wanted to create or help to create a better way to build. That was the motivation. It was partially timber framing because I thought that was a good path for a better way to build. But the real goals had to do with creating homes that, like the one I grew up in, would be beautiful and durable and functional. And because our business was founded in the 1970s in those energy crises, also, energy efficient. but also adaptable, because, I had learned, from the patron who built the house I grew up in 1895, that the really important aspect of it is the adaptability of a building so that it can serve generations of inhabitants, not just the original builders and occupants. And of course, the other part I was interested in is developing a process of building that would contain that craft ethos and a better work environment, and utilize good technology and focused on efficient off-site fabrication as we were from the beginning. And it was the practical way to approach timber framing, of course. But I ran into trouble in those early years of timber framing, of reviving timber framing, as we were calling it, because we had the task of developing new enclosure systems. The ones that were used in the houses in Walpole and Concord really couldn't work because they were infill systems kind of between the timber structures, and then that was not energy efficient or labor efficient. So we went about the task of creating new enclosure systems. This is an illustration from my first book in 1979 of one of the systems we were using. And as you can see, in that system, the electrical wires were kind of embedded in the wall and not accessible, not easy to change, certainly, not the sort of adaptability that we were seeking. But I just hadn't found the right solution yet. In my next book in 1984, and by the way, I'm happy to be here with our publisher, which is Taunton Press. It published my last books in 1984, 1994, and 1999. Taunton Press is an incredible institution, and I'm real proud to have been associated with that. But so about this, so this was in 1984. We got a little bit smarter about it. This little innovation happened on my own house, where here, I hope you can see this, there's a extended baseboard that is on the inside of the SIPS panel. And that allowed the baseboard to be accessible, run on the inside. You could easily change outlets or add wires if you needed to, and it disentangled the wiring, from the wall system, which was really, really important. It was a big innovation at the time, or it felt that way, and it was the beginning of, being dedicated to the concept of disentanglement. So in 1989, on my reading habit, I bumped into an amazing book called Supports, written by John Habraken. I hope you can get a copy. It's not always easy. You get it from the MIT Press. I think it's still available. If it is, get it. It's one of those books where I think I underlined more than I didn't. It was just incredibly illuminating, and it led to my getting in touch with John Habraken, who happened to have been the head of the architectural department at MIT for about 7 years, but he was still in Cambridge at the time when I discovered him. And so I was able to go down and meet him. We became fast friends. It led to John giving several seminars to our company on open building and dimensional coordination, and changed us for sure. So I'm indebted to John. And just, I think maybe a year later, or it might have been 2, Stuart Brand got in touch with me as he was writing and then finishing his book, How Buildings Learn. And so I had the opportunity to communicate with Stuart during that process. And once again, there's another book that was just incredibly influential in our work, and the two overlap, and they relate to each other in a way that it's just amazing, and it led to many of the developments that we went on to pursue as a company, and I'll try to describe it. So this is a Stuart Brand quote. He said, "All design is prediction, and all predictions are wrong," which I love. But the point of it is the dynamic complexity of people's lives is impossible to forecast. And so a home should not be a monument. A home should be flexible and adaptable to people's lives. That is a photo of my family, and I'm sitting on my dad's lap there, and there were 3 more children yet to come. So that's a pretty good illustration of who knew. Things are changing, and life and family life is definitely dynamic, not static. So at Habraken, what he was saying is we are housed, but the result of that housing is not static. Housing should be interactive and dynamic as life is. And so he's made the point in that book that dwelling, building, and life need to be reconnected. They've been disconnected, and we're starting to create buildings that force people to adapt to the building rather than the building adapting to people in their lives. So for me, personally, there's another aspect of it, and I think that's probably true for many listeners out there, that I think it's probably true of every builder, that we build for ourselves, and in that process, that building for ourselves is how we make our buildings affordable. And so that incremental quality of building is also a really important way in which most homes in the world are built. They are not usually built as a turnkey. Everything is perfect at that time when you move in. That's a 20th century first world thing. But the norm, throughout history is that buildings generally are built incrementally, and as lives change and families change, the building changes with it. And that's something we really need to get back to. And my point here is that buildings perhaps get finished, but in a sense, they're never complete, because life is always changing and the building should with it. So this is a Habraken principle of separating the shell from the infill. So the shell is this, kind of longer term part of a building, and the infill is a shorter term part. But he makes the point that the shell is also the part where you want public control. There are regulations there. It needs long-term durability, and because it is a public proposition, the players should be architects, engineers, and public agencies that are, helping to actually legislate the safety of it and the durability of it. But the infill really should be private. There should be more freedom there. It should be easy to change and modify. And the players impacting the infill part should be in the inhabitants themselves, maybe interior designers, other semi-professionals who are helping the inhabitants kind of keep up with the changes in their lives and personalize it for them, kind of make it their nest. So Brand, in his book, had this concept that is called the 6 S's. And the 6 S's are site, structure, skin, space plan, services, and stuff. So the site is obviously, geologic time, and things should last a very long time because the site is permanent, and therefore that work that we do as architects and designers of placing a house on the site is some of the most important work we do because the site is permanent. And the structure really should be, in a better world, it should always be a 200 to 500 year proposition. And so that includes, the foundation, the framework, and the engineering that makes it that solid. The skin is shorter time. It's 75, maybe 150 year proposition. And there's building science involved with that. The roof, the walls, the windows and doors, the siding and the trim. I think we're doing better with rain screen siding to make that easily adaptable and changeable. And then the space plan, that is how the building is organized, is even a little bit shorter. Well, let's think of it as perhaps generational. So that's the interior partitions and the cabinets and the finishes, shorter lifespan. And then services, we'll call this 1 to 10 years. Plumbing, maybe the backbone is the drainage system, lasts longer, of course, but the distribution, that changes when a bathroom changes or when a kitchen changes. So that's a shorter term thing. And the HVAC and electrical, network audio, those are all shorter term elements. And then we get down to stuff, furniture and life's junk that just changes, almost daily sometimes. So I love that concept. And so we put the two together, kind of Habraken shell and infill and Stuart Brand's 6 S's, and kind of push forward with that. And we call it the open built disentanglement, as we're trying to push a little bit further and think deeper about how we can disentangle and make buildings better and last longer. So here we have the shell kind of on the upper side of this, lasting, we hope, 250 years plus. And the infill is that blue part, the services, partitions, fixtures, finishes, amenities, all those things. And let's call those 5 to 30 years. And we think it is a way to think about buildings so that we can also create this kind of environmental responsibility on the shell side, public responsibility, planet responsibility, and not compromise on it. That's not a place where, you should save money. And as builders, we've got to stop, even saying this thing about, my clients would rather have a granite countertop than more insulation. It doesn't matter. What they need is more insulation and, better structure, and because generations from now, that will matter, even if it doesn't matter to that first inhabitant. So that's just, a paradigm that needs to be changed as soon as we can change it. And then, the infill stuff, that's where you can be flexible. You could cut back on the budget. You can do some of that stuff later. You can get inexpensive light fixtures and buy more expensive ones when you can paycheck that later. And, we have that should be personal and adaptable. And if we build the building right, we can accomplish those two sides, the shell and the infill. And then allowing all those 6S systems to be disentangled and accessible from each other. So how does it work in practice? Here's an actual project of ours, and our thinking about site structure. Of course, there's, this is us, so there's timber frame in there, and skin, and then space plan on the top, and services and stuff, the furniture and so on. And so if we think about that on the design side, then we can develop strategies and systems to ensure that disentanglement is real. Because, if we don't do that, if we entangle the services on the right-hand side with the structure on the left-hand side, then the life of the structure may be dependent on the life of the services. If we start, cutting through structure to run pipes or ducts, you're halfway to demolishing the building by the time you get it built. And so we really shouldn't be doing that. Think of the of having 110 voltage wiring in the middle of a high performance wall system. How adaptable is that? How changeable is that? And if we really expect that building is going to last 250 years, of course, that short-term wiring shouldn't have ever gotten into that long-term structure system. So it's a principle that if you follow it and if you believe in it, solutions will come. So we embarked on this path deliberately, with vigor, kind of went after it to develop the concept of how we could improve and develop systems for open-built disentanglement. And it led to a series of projects that we got involved with in order to do that. And I'll tell you about just one. I'll tell you about one or two of them. But we developed a partnership with MIT for this purpose and some other partners. And that led to the open building prototype. And we did two projects in that partnership in 2006 and 2008. We did the Loblolly House in 2006, a private house for a professor from UMass who believed in the vision too. In 2007, this old house was another project that we pushed and pulled on our prototyping. And then the Wentworth Zoom that we took to Greenbuild in 2015, most recently, and a lot of prototyping in between. But as an example, here's one of the first prototype projects we did with MIT. And the project was actually a two-family halfway house in a brain injury rehabilitation center at Crotchet Mountain. And so therefore, given the clients, this building had to be extremely adaptable because the clients who lived in the halfway house, were constantly changing with constantly changing needs. So the rooms actually had to be movable and all the systems need to be upgradable as needed. So elements here that we developed, one was this mechanical core wall that had all of the intensive mechanical systems built into a central wall. And the whole concept of this wall developed or kind of redeveloped from a similar concept that was developed in Germany. That whole core wall could be actually removed from the building and replaced with upgraded mechanical systems. So it actually passes right through the center of the building and up into the roof system. We developed this wainscot system that has wiring behind it on several levels, and the wainscot is completely removable. There's that upper cap that you just pull off, and then the wainscot itself can be easily removed, exposing that entire space for changing the mechanical system. We developed a demountable partition wall for that system because all those partitions in that space needed to be able to be removed when necessary, not if necessary, because clients were changing. We developed a floor system that could be placed kind of over a timber structure, and the floor system separated the mechanicals from the structure. And all we had to do, once we had developed this, which was a brilliant system, by the way, and I take no credit for it other than arguing a lot, but it was developed by some good people in our company and continues to be developed today. But with this system, You have open access to all the mechanical systems, ducts and pipes and wires. And then we developed a ceiling system. Oh, here's ducts and a radiant heating system attached kind of in that floor system area. And then we developed a ceiling system that was demountable. So we just, created these ceiling panels in our shop here, actually right behind me. And then we could take them out and install them kind of as a removable ceiling panel system over the timber structure. So we've done that system in probably hundreds of houses, often with pine boards or something similar, but sometimes with MDF, as you see on the upper right there. And it's a system we still use today, the Versa ceiling system. And here's another ceiling system that we developed in conjunction with TJI's. We've called it the Grip T system. We actually make those metal grips ourselves, make them right here, or we used to make them here. And then we hang a T-bar from the TJI and allowing us to do a ceiling system similar to what we do with a timber structure, but with a conventional structure. And here's a channel base. We went on from the system that I developed in my own house to perfect a baseboard system that we've used in many, many houses. And part of the innovation is to ensure that that baseboard is easily removable with a cap, and then separate elements for the outlet boxes, so that you can move them easily. And I can report I have several of those in my house, and I have moved outlets to be closer to the lamp instead of extending cords further to the outlet. So there you can see that outlet box concept in a little more detail. For interior partitions, this is something we've experimented with. It has not become kind of mainstream for us, but it's a base element that we can use on our non-structural partitions, so that once again we're able to run wires freely, through that base element, and then up into switch boxes and outlets as necessary. But again, providing easy access to that base element. In 2007 and 8, we developed this, what we call the OBPlus wall system. Kind of after we got beyond, well, I should be careful about this. When we stopped using SIPs as a system and developed our own wall system, one of the most important ingredients was to ensure that we had a way to, flexibly move wires and pipes. So, of course, there's a complete service layer, in this wall system that is critical to how it functions. And all the wall systems we offer today have that service area as a part of the system, and it's just really important. If we think these buildings are going to last a long time, and we've got R35s and R40 and 48 in the wall systems, to entangle it with services and wires is just a crime, and would limit the life and durability of the building. Here's something else that we've done, not on a regular basis, but more on a prototype basis. We've off-site build mechanical cartridges that can be installed kind of separately, and therefore, taken out separately. Kind of a more flexible system. Of course, it has to be put into the right place in the home to be that flexible, but of course, we're doing that as we disentangle the services from the structure. This kind of brings us up to date. We're working on a new kind of brand for the company, and we're developing a new kind of ceiling panel. Just it'll function in much the same way as our older ceiling panel, but it will have a different kind of grip system so that we can align the boards in a different way and have kind of a continuous ceiling system, even though it is totally demountable and flexible. And then I thought everyone would be interested in this. We've done a lot of experimenting with plug and play systems in plumbing and electrical. Unfortunately, the most flexible systems that we've used and actually installed in buildings come from Germany, and they're not UL approved, but we live in New Hampshire where, you know, it's live free or die. So, so we've actually installed some of these systems, experimenting with the flexibility of a complete plug and play system. And, you know, I do think this is going to come to our country, and we're right on the task of trying to develop a system like this that would allow us to kind of distribute a complete electrical system that is plug and play and accessible. That's kind of the holy grail. So this system was in Open 1 because it was in New Hampshire and we could do that. And we've experimented with it on a couple of other projects. And I thought I'm just going to end with this because it's kind of fun. And it allows me to ensure that we're not taking too much credit for everything. So I always say, you know, we've learned from everywhere and borrowed ideas from all over the world. That's, you know, I guess that makes us American. And so, you know, so many things that we have developed on around our company have come from or learned from standing on the shoulders of other people in the world. And so I circled this open building that came so much from John Habraken and Holland and of course Stuart Brandt here. But I am indebted to John, who, by the way, is in his 90s and I think deteriorating a little bit. And so I think about John a lot and always publicly want to thank him for all that he's done to advance our thinking and advance our systems. And this last slide, this is a little bit embarrassing, but you'll see open building over here that we started in the 1990s. This is our whole company history, or my history, in a slide. And we've started here. We're continuing today to develop the open built systems, but so many other things that are critical to that idea of a better way to build. That's so I want to thank everyone for listening. If you did and you're not gone, you know, I realize that it's a little bit academic, some of it, but the academic part is actually really, really important because it's not just about finding a way to build a better baseboard system that disentangles wires. It's really about rethinking the process and the product of buildings so that buildings can last longer and be more adaptable to people's lives and be more responsible to our indebtedness to the planet for giving us the gift of life. So thank you for paying attention if you did.
Ted, thank you so much. That's an excellent presentation. The chat box is going crazy with people. It's basically virtual applause. So, you know, it's sort of a standing ovation in virtual terms. We really are very, very grateful for you preparing that and sharing that with us. It was excellent. There's about a page and a half of notes here, and I could ask you questions probably for the next 6 to 8 weeks if you can just stay on. Or we could go ahead and engage our wonderful audience and some of the questions that popped up through the chat box. I just, on a personal level, I'm just extremely struck by the vein of responsibility that has run through what you're doing, not just responsibility to your fellow man, but to the planet. And the idea of these modular components, and basically I can envision your homes that you're building now and since the 90s being essentially disassembled and reassembled into various different rooms and spaces. And I realize that's your intent, but that's sort of the responsible model here. Like we talk about the homes of Europe where the guy moves in and he puts down his own floor and his flat pack cabinets get assembled, and then, well, he doesn't necessarily want to stay there and he moves to the next town in a couple of years, different job or whatever, and he packs up his flooring and his cabinets and he takes it all with him. Your homes work the same way within their own system or within other systems or within other homes that you've built. And I have a tremendous admiration for that. So I'll let other people get their questions in, but I wanted to applaud you, not just virtually, but thank you again.
Thank you, Travis. I appreciate that. And again, this whole thing is humbling. We're on a path. I don't want to pretend that we perfected this or we're at the end of a adventure here. We're really, very much at the beginning. And one of the most important things that could happen is that this could become a little bit of a movement in the building industry, because the real solutions, will require some transformations of the system and how we think and how we work.
And Ted, have you seen? You've spoken about this at quite a bit, and you published an article about this in Fine Home Building. And have you seen and traction? Have you seen? I know this idea certainly hasn't hit mainstream building yet, but have you seen traction with any custom builders? Do you see any of do you have any peers that have picked up some of this stuff and started using it?
Honestly, not really in the home building industry. In the commercial industry, absolutely, and in industrial building, absolutely. This is how hospitals are built. They have service layers that are 2 feet deep, and think about buildings that are designed, for the commercial activity. Often they're designed without a tenant.
Right.
They don't know who the tenant is going to be. And so they're designing for what we call capacity rather than designing for a particular outcome. And that's a really rich concept if you think about it. Designing for capacity, what can this building do? What could it be? And how could it not be stuck in time? Is kind of an interesting way of thinking about, how to make a building that is adaptable. The way it's, in the commercial world, they already do it. Yeah.
You also mentioned, you kind of noted early in your presentation that timber framing, when you were talking about timber framing, you mentioned that it made a lot of sense, timber framing, to be combined with offsite construction. And I wonder if you could, that sort of makes sense whether, I think to me, it makes sense whether you're building this kind of open concept or not. And I think there's a lot of, and I think a lot of people here would agree that there's a lot of benefits to offsite construction. But I'm curious specifically if there are good reasons why, when you're building this way, when you're building with this open concept, offsite construction becomes even more helpful or more important to the process.
Well, starting with timber framing, clearly that was the way we were going to be able to revive it, by using stationary tools and shop systems where we could actually create the cutting and shaping of timbers in a more controlled environment. So it was just key to how we did it. But in answer to your question, it actually goes a little bit the other way, that offsite fabrication has a tremendous promise, I think, of course, because that's what we do. And part of the solution for offsite building, to make offsite building more practical and more universal, is that the building components that are fabricated offsite, benefit by being disentangled when you get to the site, so that the systems can be installed, by separate trades if need be, but in separate components, free of each other instead of entangled in each other. So if we're creating a wall system, just to use that example that I've kept using, if we create a wall system that is not entangled, we as carpenters can do it. If it was entangled with wiring and plumbing and ducting and so on, it would take, 5 trades
Right.
to have accomplished the same thing. So by disentangling it, it's more adaptable, but by disentangling it, we actually set it up for success in offsite fabrication. And then, the on-site assembly, what we call montage, can then be executed efficiently, maybe more efficiently in that environment, but with offsite elements that were, fabricated elsewhere. And there's, some really good examples of that. I visited we don't do this yet, but this is our aspiration. There's a really good home building company in Sweden called Lindbäcks. And they among the things they make are, the plumbing systems and the electrical systems and all of that. And the plumbing systems are created there as complete elements, with the elbows in place and the connectors in place, so that they can go to the site ready to install, or they're installed in their in their elements in the factory, but kind of underneath or to the side. I should mention something else, since I talked about that, because I forgot to include this in the presentation. So this hasn't taken hold in this country, and I was telling you guys as we started here that this is the first time I've been asked to talk about this. So thank you. You're setting up something that's good. So it really hasn't taken hold here for sure. But in Japan, they are doing this hook, line, and sinker. John Habraken spent a lot of time in Japan, and the audiences took notes, and they did something with it. And so today, they're in Japan. There's what they call the long life building law. The long life building law, and so it's embedded in the code. And if you build to the long life building law, meaning applying open building systems, then there are tax incentives, for doing that. And as a result, thousands of buildings have been built in Japan that, apply open building principles. And one of them is really interesting because it has to do with multifamily buildings, that part of the principle that they're enforcing with the long life building law is that the apartments or the living quarters have to be able to be the systems have to be able to be upgraded without disturbing the inhabitants. So meaning they need to be accessible to the trades, kind of in another area, beneath, around, below, on top, but not embedded, in the environment. And so, they've developed some very creative solutions for that. And that is connected to my comment about Lindbäcks, because Lindbäcks also employs some of those same solutions in their multifamily buildings in Sweden.
One of the things that's interesting to me about the disentanglement idea is that starting to see so many high performance builders doing that for a different reason, to protect that envelope for air sealing reasons and whatnot. And we're starting to see them framing chases below their air barrier to run mechanicals in. And they're not talking about what you're talking about, but they're doing it anyway, which is interesting, that it has sort of that kind of that double benefit. Mike, were you going to jump in?
Just a quick question. I think we've had a couple of questions just to clarify, Ted, although you obviously started with timber framing and that's still an integral part of what you do, this whole thing works without timber framing, right? Timber framing is optional. Your walls and roof and everything can be built without heavy timbers. If you're trying to get the cost down, then timbers aren't required, right?
Right. So I should say that our Unity homes, that I think some of you know about, but if you don't, please check on the unityhomes.com and look at those houses. Most of those are not timber frame, and so the answer is yes. However, in most of those buildings, in the trad, in the VARM, and the Zoom, there's actually interior column and beam support for the structure. And the column and beam support, you could call it a timber frame. It's really column and beam. It could be anything, but it's not the interior partitions. So there are no load-bearing partitions in these buildings separating the structure from the infill. And so that's the principle. And so in the VARM, as an example, there's kind of one linear line of column and beam supports, to kind of break up the span. So that's the principle. And once again, I could say we were pretty creative about that, but it's totally common in commercial buildings that, the same ones that we're talking about, that there's a column and beam structure in these kind of open environments that don't have tenants yet, allowing the tenants to come in and put partitions and, whatever they're going to include in their store or retail shop. So it's an easy concept to ensure that you've separated the structure from the space plan.
Yeah. And maybe I was trying to think of ways. I mean, obviously this is the way every new house should be built. It's a big leap, but just one small way I've seen sort of that concept implemented is I know a lot of builders frame all of the walls, interior and exterior walls, all at the same time. Then they run all of their joists, so everything is fully connected. The way I learned to a stick frame is you build your exterior walls, you build your center beam, and you frame your floors. The goal is to get the roof dried in as quickly as possible, and you don't want to get slowed down by standing partition walls and trying to brace them and all that. So just it's one little baby step towards where you're trying to get, but it's maybe something that other builders could adopt with very little change. All you have to do is just you build the structural walls, and that's it.
Absolutely.
Yeah.
A perfect example. Just put a column there and make it beautiful, because it might be exposed.
Right.
Right. So we had a few people in different ways have asked if you get any pushback with these ways of building from building officials, lenders, insurers, and anyone who can push back against doing something different when we're building.
Well, to be honest, we don't talk about it much, and if it shows up in the prints that we bring to building inspectors, I'm not sure what they would jump out at them. So, I mean, there are things like, do you have enough depth for that electrical box? Well, we do have to have, we have to abide by the code on those kinds of things, and there are ways. There are places where we can't put wires, or we'd have to have conduits. So we have to follow all of that. But, once you're past that, the finished home looks like any other home.
Yeah.
With some cool features, like the suspended ceiling system. And you'd say, well, that's an odd looking system. What are all those battens up there? Or you'd say, well, that's a really beautiful ceiling. How did you do that? So we do talk with our clients about it, only for the aesthetic outcome, not so much for functionally how we're going about creating it. But I can't remember ever having pushback from a building inspector or another professional. However, I haven't been able to get architects to work with us in this way. So they're not all on board, sold by Tedd. So, they get it, and a lot of people like it, but it's actually kind of a unique way of thinking, about the building, and it's a little bit different. By the way, the Habraken proposition is really provocative. Here's John Habraken, who was the head of the architectural department at MIT, and then practiced. He was a professor at MIT for another 8 or 10 years, and part of his proposition is that architects should stop architecting when the shell is done. Just stop and find a way to leave that to others. And don't try to make a monument, there for yourself and feel like you need to have control of everything. Hand over the control to others. So it was pretty provocative proposition that, he carried his whole professional life. And I really respect him because he did not get a lot of accolades from, many of his colleagues for that. Although, he's still, of course, very respected around the world.
I know since this is your life's work and it's still not adopted on a mass scale. I'm not sure if you have a direct answer, but Armando has asked in a couple of ways, and it's a good question. Just how do we start to scale these ideas? If it works in Sweden, in Sweden and other places in Europe, it works in Japan. I know the U.S. is unique in a lot of ways, and there are small companies here and there doing it. But what are your thoughts on how do we realistically make this happen? Well,
I think I think now it's up to the Beer and BS group. you asked me to give a pitch. Now you own it.
All right. All right. Fair enough.
But I've been talking about it for years, including in front of architects and architect groups and builders and builder professionals and generally nobody has said that's stupid or it's a bad idea, but it just doesn't get the play that you might expect for an idea that really makes so much sense for the building industry. It's kind of heard and forgotten, and maybe it will be again tonight, but maybe it won't.
Right.
And there's some people here who will grab it and take it forward. Our company is absolutely dedicated to it, and I'm very thankful to my colleagues who have done so much to advance the ideas, the thinking and the innovations. As I say, this wouldn't have happened if it were just Tedd.
Sure.
It happened because there's a whole big team of associates and alumni who've helped to create this. Sure. So I do hope that there will be some inspiration out there about the idea, and we can kind of carry on a conversation about it. It'd be great if there were whole seminars about how the industry could move forward kind of in a different way and design and engineer buildings to be kind of fundamentally to be adaptable with the same determination that we have to make them energy efficient. Because that energy efficiency that we're creating brings with it an obligation that we have. Because all of us, we're creating walls that are 10, 12, 14 inches thick, and they have a lot of building materials in them. And that work that you guys are doing in this group, that the good building science, creates a building that will be energy efficient for as long as it lasts. So how long is it going to last? Becomes the question. And so we have an equal responsibility, I think, to embed in the design of the building and the engineering of the building those elements that will ensure that it has the opportunity to, to last many, many generations, like the home I grew up in.
Right.
I couldn't agree with you more, Ted. I want to touch on a couple elements that I think are sort of the entry level or the baby steps for a lot of us builders to move this direction. And I think that's where scalability starts. I think broad adoption of what I would consider relatively minor changes to what we're doing now, it moves us in that right direction without necessarily being a huge cost prohibitive measure that takes a lot of people out of it. Something that I think that production builders could do pretty easily would be, an LVL band joist at your top plate that would essentially eliminate the need for all of your headers at all your window and door locations, making that a very easy change if you were going to have to add an addition and you wanted a large cased opening, or, the changes that you've already talked through. I realize that it's foolish to just throw a bunch of money into a house at the front end and make it not available to people because it's too expensive. But I feel like we're already putting a rim on a multi-story home or a band joist, depending on where you're from. The idea of eliminating that thermal bridge has an energy benefit too. So then if we're talking about doing that, maybe we're talking about an open web truss ceiling system or floor system that gives you that mechanical chase. And now instead of, or, in the case of a crawl space or a basement, Emily's not here to complain about how bad basements are. But in her absence, I will say, I like going into the basement and standing up to work on mechanical systems. I find it very easy to do. And if you are going to move all your partition walls around, that's a pretty easy change for your electrical, your HVAC. That's all very attainable without necessarily throwing everything in the landfill. I realize we're probably, if we're continuing to build with sheetrock as our primary, drywall, if we're going to continue to use drywall as one of our primary interior finishes, there is going to be some waste with that, but it doesn't have to be as bad as it is now. And I do think there are some elements that can be very simple baby steps. I think your baseboard detail is one that could be used on most every wall system I'm familiar with. There's not really a downside to that. I realize it doesn't necessarily service your kitchen. You're still going to have your high load circuits there for your appliances, and those are going to be at higher levels. You don't want your baseboard running 4 feet up the wall, but there's a good application for a deeper cabinet that sits out, or maybe you lose 2 inches from inside your cabinet, and that's the solution. So there are scalable opportunities if we all start somewhere and just keep moving it forward. We'll get there.
Yeah. Your example about a kitchen, that actually gets pretty well solved with a complete service layer, because it's not just the baseboard. It sort of gives you that space, kind of all the way up the wall. So we've had a much easier time with our kitchens recently, with that service layer there than previously. The other thing I might have mentioned, had we had, another hour, is this whole opportunity that I hope, kind of was made apparent to you, that if we could separate the shell from the infill, and it's kind of public from private, and, thinking about it like, the commercial areas, my thinking is banks should finance the shell differently from the infill. We've got, this 30-year mortgage for a shell or for a building, but if we have a long-term proposition for the shell, why couldn't it be 50 years or, longer? Because it's so much in the public's interest, to have long-term propositions instead of short-term propositions, and to build it right, as a 100, 200-year building, it makes sense to me that it, be financed with a different kind of mortgage. So I've made that pitch to bankers. Why couldn't it be? They do it in other countries. And then the infill, a little bit more, like your car, or paycheck, and kind of a different way of financing should go along with a different way of building. I'll bet most builders here, and I'm not seeing all of you, but I am too, actually. But I'll bet most builders here, if you built for yourselves, you probably built incrementally, and you moved in before it was done. And you probably still have some trim that you haven't installed yet. So, as builders, we should be believing in this, the whole idea that, buildings should be allowed to be incrementally built as a method of affordability. So if we have this long-term shell, why couldn't we move in and, finish the kitchen and the bathroom and sleep in the dining room until we get the bedroom done? And homes should allow that. And I tell that story because that's what I did. I moved into a shell and had half a kitchen and most of a bathroom, and we slept in the dining room. But the kids were little and it didn't matter. But later, we installed, more partitions and added more infrastructure, and it's why I was able to afford it. I couldn't have if it had to be turnkey. So this whole concept of requiring buildings to be completed and inspected, all the way down to, finished cabinets is just silly. And it blocks so many people out of, being able to build a home. I was talking to a prospective Unity client a couple of days ago, and, sad conversation. She couldn't quite afford, our home. And, but, she made the point that I only need a kitchen and, this bathroom, and I could move in, but the bank won't let me. And so it's, there's a frustrating aspect to this as well about how do we get to affordability. Might also, have open building as a solution.
Brian Schultz had a good question in the comments about slabs on grade. I know they're standard in a lot of the country, and even in the Northeast, where we mostly do basements. Those of us wanting to build greener are often trying to build on slabs to reduce materials and all the bad things that happen in basements. Now that we're trying to reduce concrete, some of us are trying to build concrete-free slabs. But anything under a slab is not accessible. So do you prefer crawl spaces for the accessibility? Is that a better long-term strategy to sort of split the difference? What do you think about foundations?
Well, a crawl space is a good strategy. Is it a better strategy? That's a question. When we did Open 2, the second open prototype, that was on a slab. And what we did there is we separated what we call the backbone of the system from the distribution of the system. And the backbone we put into an accessible trench, that was a part of the slab, but an accessible part of the slab. And then the distribution, went into the slab rather than, all the drainage system and all the water supply system. So that's one solution we've done. Another is to kind of intensely put the primary mechanical elements located in kind of one part of the slab and make that a crawl space.
Okay, yes.
And not the entire slab, and allow some distribution to go through the concrete, but not everything.
Mm-hmm. That makes sense. Yeah, I got an image of Louis Kahn's. I'm blanking on the building in San Luis Obispo. It has this long trench running down the middle of the courtyard. I can see the house slab with just this channel in the middle where you run your main drain line. So.
Well, it could be a feature, right?
Yeah, exactly. Yeah, make it a feature. Yes. Salk Institute. Thank you, Daniel. Salk Institute.
Yeah, so the floor changes in the area where you need accessibility. That's not such a bad idea.
Right.
One of the early on, Ted, someone had asked about, I forget how they phrased the question, but the note I wrote down was the evolution of your insulation package. So I wonder if you could just share a little bit how your, at this point, what does your shell actually look like? The
evolution, or what is it now?
Well, I don't know how. I think what it now is more useful. They had the questioner had asked about evolution of your insulation package, but I think what you're doing now is probably the more useful response.
Yeah. Well, I will say, and again, I need to be a little bit careful about this, but we spent many years using SIPs as an enclosure system, and I wrote about it and promoted it in 3 books. So, all in, right? But eventually we did get away from it for several reasons. One is this whole thing about how to deal with mechanical systems. It's pretty difficult with a SIP. To run wires in the middle of a SIP is just nutty. We tried it. I think people are still attempting that, but it's not easy, and it doesn't necessarily make a whole lot of sense. But really what kind of got us pulled in a different direction is eventually, we understood that the only responsible way to deliver SIPs to a site is pre-cut. Because otherwise, on the site, you're going to be cutting foam and, leaving foam waste, on that building site. We had a project where that happened, and it was the owner owned a cranberry bog. It was not good when his cranberry bog turned green, after a windstorm. So we just realized, this is not good. The right way to do it is to pre-cut it and deliver a package to the site with finished SIPs. But that meant that all of the waste was here at our landfill in our backyard. And then we're like really seeing it. It's like, holy mackerel, we're going to be the bane of Cheshire County with, all this waste that is, you can't easily recycle it or anything like that. It's a sandwich composite. And so that was really, one of the primary reasons. We just said, this is too much waste of the wrong kind of material. But when we got into building our own wall systems, we also realized that by building a complete wall system, not only could we eliminate the waste, but we could build in really good open building solutions kind of anywhere in the assembly. Along a door jamb, we could actually create a cavity. So it could be horizontal, it could be vertical. We got to have this whole service layer. But because we're building it, we have so much control over the quality of it, but also the adaptability of it. And just huge advantages and to have that level of control and no waste.
In terms of process, I know you said, or I know John Habraken said get the architects out of the way, essentially. But just, in terms of process and working with you, or companies like yours, not that there's a lot. Just how would an architect or designer who's used to doing conventional or maybe slightly unconventional work, how do you find a builder who's willing to do this kind of thing, or do you ship nationwide, or just what's a practical boots on the ground process for somebody who wants to do this tomorrow?
Okay, so all of our building systems are kind of available to anybody across the country, but and that's under tectonics, and that would mean your own architect, your own engineer, and basically our building systems. And the way it works is that you would include our building systems using something like a Revit template or a SketchUp template, to include our building systems and those dimensions, in your system. And then, we can deliver the floor panels, the wall panels, and the roof panels according to your plans. I made that sound easy. Usually the plans need to be changed or adapted or upgraded in some way, so we'll have some input about that. But mostly it can work. I think you all know that we worked with Emily Mottram on a project just like that. And of course, she's a good architect, and she designs good buildings that are pretty simple in their massing. And so it was not so hard to include our building systems in her design. I wish she was here to talk to that. But she's actually one of the earliest tectonics architects. And so we use her as an example for other architects.
Nice.
And we're working with many architects now, of course. And generally it works well, but sometimes there's some negotiation, we'll call it.
I think this question from Jeremy I'm just going to read this one. It might be a good one. It might be a good last question. He says, Ted, your honesty and humility is refreshing and inspiring. I think everyone agrees with that. We're following the footsteps of your work, attempting to anyway, with clean prefab systems here in Canada. We're struggling to serve the folks with lower budgets outside the custom market, and we love your advice and or experience on how we might move towards serving that market as we grow.
So I don't know about the company or the product, but this will give me a little opportunity that may lead to your inviting me again someday. But I really think one of the things our industry is missing that it would change everything for companies like his and ours and maybe a lot of you out there is standardization, dimensional coordination. And so this was another thing that we gleaned initially from John Habraken. And so all of the buildings we do have a macro grid and a micro grid, and all the elements that we design with fall onto the grid: the structural system, the finished systems, the mechanical systems, the interior partitions. Everything actually fits a grid, and that would allow his company, if we adopted this standardization together, we could actually work together. His systems and our systems would then be compatible with each other. And so this is another thing that I've been ranting about, for a long time. And yet I think we're maybe the only residential company in North America that is using, dimensional coordination as a standard. But think how powerful that is. It means that, for instance, in Unity homes, we actually don't have to design the homes. We assemble the homes, digitally assemble the homes, because all the components are standardized: the bathrooms, the kitchens, the partition locations sort of snap to rule. Stairs are standardized, and they all fit. Everything fits like a Lego, because there's some standards behind it that inform it. And it doesn't mean that you can't customize. You just can't customize out of the infinite sea of possibility. You can customize out of kind of units and increments that would make sense. So that is allowing us to make our buildings ever more affordable, simply because then the components that we make are standardized: the doors, the stairs, the bathrooms, the kitchens. Everything is sort of standardized, and they're a lot less expensive, just with us doing it. But if he did it and we did it and you did it, we could actually create a whole lot more efficiency across the industry. And I think it's the next thing, closely connected to open building is dimensional coordination and the impact that could have across the industry if we all did something with it. I don't know if you guys have been watching the McKinsey reports, but there was an incredibly good one in 2017, kind of about the problems in the building industry and the lack of efficiency. And the construction industry just lags behind most other industries, and so they described it quite well, the problems, and there's plenty of graphs there to prove it. But they also kind of put forward, here's what we could do to fix it. And the first thing on the list was standardization. If the industry could adopt some standardization, then we could kind of connect the dots, and then somebody out there could be delivering an electrical system to us that would fit, like a wiring harness that would fit, and or a plumbing assembly that would fit, or interior partitions that would fit, and we wouldn't have to make all of that. All we need is some basic standards. McKinsey report so that was 2017. They just came out with another one a couple of weeks ago, and it has to do with the impact of the COVID crisis on the industry. And so that's worth reading too. And one of the things they pointed out is, that the COVID crisis is sort of accelerating all of those changes. And the first thing on the list, and the one that came out a couple of weeks ago, was standardization. and they believe that this is going to spur kind of a revolution in that, because now the industry needs it. There needs to be some basis for the industry to be connected and have some standards so that we can actually make components off-site by some rules, so that when they get to site, there's a reason why they would fit, because they're following the same rules.
You make another excellent point, Ted. The whole standardization process, I think, gets a harsh look perhaps from designers who want to be able to be creative, and everybody wants their own aesthetic when they move into a house, and they want everything to be customizable. But I always try to remind people that we have a standard dimension of lumber that everyone's already using, and we're all used to it, and it's not hard. So the broader adoption of standardization, as you described, is really a giant leap forward in efficiency and in saving the resources that are so precious. We are kind of at the end of our time for the night, but I don't want to kick anyone out of here without saying once again how much we appreciate your influence in the industry over this long period of time, and certainly your time and presentation tonight. And thanks to everyone who joined us for the chat tonight and the discussion. Thanks to Green Building Advisor and Fine Home Building as always. And Brian, is there a way for the chat to continue on Green Building Advisor? Can you remind me how that works?
Well, this video will be live on Sunday, and there's plenty of space to chat on GBA. So head over there on Sunday and ask your questions. And Ted, by the way, you don't even know that you just pitched me a great Fine Home Building article, so expect me to be bugging you very soon.
All right. And I want to thank you and all the listeners. It's honestly, it's a little bit of an honor to be chatting about this, and to this group of dedicated builders. Thank you for all you're doing out there to improve the industry.
It's a pleasure. Thanks to everyone. Good night.
Thanks. Have a good night.